Hi folks, we're going to take a look at number 10, B and C on page 254. And I want to talk about both of them at the same time because they're actually very similar problems. All right. Now, if you watched one of the other videos, you'd have heard me say that any time you see an expression that's made up of two other expressions and a subtraction in between, this one here, I got 225, I have x plus 5 squared, a difference between them. Same thing here, 3c plus 2 squared, 3c minus 2 squared with a difference between them. You should be asking yourself, can it be factored as a difference of squares? So let's recall what a difference of squares looks like. So in its most general form, I can say a squared minus b squared. So anytime I have two expressions squared that are being subtracted, this can be factored as a plus b times a minus b. Okay, so in other words, the first plus the last times the first minus the last. All right, so can this be seen as a difference of squares? Well, this is where, if you do a little arithmetic, you realize that 225 is a perfect square. So this can be written as 15 squared. And this is already written as a perfect square. Okay, this expression, x plus 5, is being squared. Now, normally, the examples we've seen so far had actual numbers or just monomials that were being squared. But here we see that it could even be something more complex. So if I compare this to my general expression here, my a value is just 15, and my b value would just be represented by x plus 5. So now I can go ahead and do the factorization. So what did we say it was going to be? It's the first plus the last times the first minus the last. All right, and there's our factorization. Okay. Now I want you to see that we can actually go further because I can simplify both of these two expressions. But before I do that, I want to make sure it's very clear why I use these brackets here. Because when I'm adding a plus b, I need to be adding the whole term b. Okay. Now, in this bracket, it actually doesn't make a difference whether I put the parentheses around the x plus 5 because the addition will be the same with or without the parentheses. But here it will make a difference. If I don't put the parentheses, the negative sign is only going to apply to the x, but it actually needs to apply to the whole term. I'm subtracting this whole expression. Okay, so my suggestion is always put the brackets. Even though you didn't need them here, if you use them in every instance, you're not going to forget them when they are necessary. Okay, so let's just simplify this here. So here the brackets make no difference. There's the addition. So I have x, and then here I have 15 plus 5 is going to be plus 20. Okay, and when I simplify this here, well, I see that I have a negative x, because remember this negative 1 needs to be distributed to both terms. So I'm going to have a negative x, okay, and then here I'm going to have 15 minus 5. So plus 10. All right, and there's the factorization. Now, unfortunately, if I were to distribute this out, I can't easily see that I have the right answer. I'd have to distribute out both of them, and I would see that they would give me the exact same answer. Okay, so again, look for anything that could be a difference of squares. So I come here and I see, well, I already have it as a difference of squares. So in this case here, a is just 3c plus 2, and b would be 3c minus 2. Okay, so now we can write our factorization, the first plus the second times the first minus the second. Okay, so here we have 3c plus 2. So see, I'm using brackets, even though I don't necessarily need them, plus 3c minus 2. And then the second one, we have 3c plus 2 minus 3c minus 2. All right, so there's our factorization, but of course we can see that this can be simplified. Okay, now I'm going to do this in a couple of steps. Normally I would expect you to start doing this all in one step. So here 3c plus 3c is 6c, and 2 plus negative 2. Okay, well that's just the same as 2 minus 2, so I'm just left with 6c. Okay, let's take a look at this one here. This one I'm actually going to write out. Okay, so 3c plus 2 from my first bracket, and then remember I have to distribute this negative 1 to both terms, so I'm going to have minus 3c, and negative 1 times negative 2 plus 2. Okay, I think you'll see something really interesting happens when I simplify this, because 3c minus 3c, that's just equal to 0. I'm just left with 2 plus 2 is 4. And look at what this simplifies to. Something really, really simple. This is just going to end up being 24c. All right, and here's where we start to see the power of algebra, how you could take something which looks fairly complex, all right, but reduces to something really simple. Okay, so just to recap here, you need to start recognizing that when you see two expressions that are being subtracted, it could very well be that they represent a difference of squares. Here was a little more obvious because you saw a square minus another square. Here you had to recognize that 225 was equal to 15 squared. Okay, that's it for these.